Hello, everyone, and welcome to the fourth episode of Glamorous Toolkit Live. Today, we're going to talk about moldable analysis, or the idea of supporting technical decision making by means of custom analysis. So, for a case study here, we chose a Java system. It's a case study that we're using often for teaching purposes. The case study here is called ArgoUML. And what we have here, there's already an existing playground. And in this playground, we already have some file which is called argouml.msc. And if we look at it, it's a file that contains some serialization of the Java code that makes up ArgoUML. And this MSC file was actually, in this case, created with an external tool called JDD2Famix. And it produces this intermediary format that then afterwards we can load. So what you're seeing here is we have here a model, and in this model, we're gonna read from this MSC file, and we are setting what the root folder is. And if we're executing this, we get this kind of a model at the end. Okay, but before we go into the details of the specific exercise that we're gonna tackle today, let's talk a little bit about the reason why we want to employ these kinds of analysis and why we would need even custom analysis. Andre is going to pair with me today, if he can. So the primary reason for, in fact, why we started Glamorous Toolkit at all was this idea that developers spend most of their time reading code. So somewhere around 50, maybe 50% or more of their time reading code. And the problem here is that this time is very often being spent implicitly. In other words, we don't really talk about how we read code. And well, that would not be so much of a problem if this 50% or more wouldn't mean that this is the single largest expense we have. So if it's, when we are talking about that kind of a budget, it means that, so like 50% or more means that we are spending the largest chunk of our budget on one single activity nobody talks about. And if you don't talk about it, it's not explicit. If it's not explicit, it has never been optimized. And it's not a good thing to not optimize where you're spending the largest time of the energy. Now, if you think about why do developers read code, is because there are many ways to read code, and there are maybe also many reasons. Let's say, for example, if you're opening or starting with a new programming language, you would start to read code in a certain way so that you can learn the language. But when you're developing a system, you're reading code in a much more specific way. And in that way is you're reading code with the idea of understanding enough about the system, about the problem that you're focused on that system. So you want to understand enough to be able to actually make a decision. And so from that perspective, we're actually looking at the whole software engineering, given that this is what we're spending most of our time on. We look at software engineering as being primarily a decision-making business rather than a construction business. And so the primary reason for why we've constructed Glamorous Toolkit was to actually address that problem. It turns out that the principles that come from it, so this idea of moldable development, of creating custom tools, has further reaching consequences than that, but that is where we started from. And before we started Glamorous Toolkit, we actually worked on another system which was called Moose. You can still find it at moosetechnology.org. In fact, Glamorous Toolkit ships with the core of Moose. And so Moose is like a plugin, if you want, inside Glamorous Toolkit, and it can be used for specific kinds of analysis purposes or software analysis purposes. So what does it mean to have a model? So we see here that I have a variable which is called model, which is, I can also see here, it's an instance of Moose model. So a model is a representation of some system, of some target system, and in this case we are representing the whole um, the whole Java code base in this case, as if it would be a database of of interconnected entities. So what kind of entities are we talking about here? So for example, here we have all the classes, or in all the classes in this system. And we have here, there are all the methods in this system. So I can see here, I have 19,000 methods and 2,300 classes. But we also have information about invocations. And so these are the entities from that represent how a method calls another method, right? And or equally accesses, or even things such as annotations. So here we see, for example, that in this system there are 6 annotations being used. So deprecated, override, suppress warning, inherited retentions, and a custom one here, UML model mutator. Okay, but so this is a technical thing of how we're approaching analysis. So essentially, we look at a system, even if it is written in another language, and what do we do with it? Well, we do what we do best. That is, we represent things as objects, and once we have them as objects, magic things can happen. Because once I have, let's say, if I have here all the classes, and if I click on a class, then what do I see? Okay, I see an instance of we call it Famix class. Famix is the name of the meta model, the representation model of source code. And notice how now this is an instance. So I have an object that represents a Java class. And so on the one hand, I might be able to see, I want to see all the methods in there, or maybe I want to see attributes. I can see it has 3 methods, 3 attributes. And then I can also look at it like this. So I can see visualizations. This is called a class blueprint. And so, yeah, so once we have objects, we are employing exactly the same tools and techniques that we are doing, that we're employing for any other problem that we are having inside Glamorous Toolkit. That is, we're just having the inspectors, the views, and start having these combinations, and especially the combinations with coding and with the querying part is where the power comes from. Okay, now, again, this is a technical part. Now, it doesn't matter how interesting or fancy a tool is, it is only interesting if it actually changes somebody's mind. If, in other words, if you would, after using a tool, after doing an analysis, if you have a chance of thinking something differently or deciding something differently than if you wouldn't have employed that analysis. And that's exactly why we should never start from the tool. We should always start from a problem. So let's take a problem here. So as an exercise, and that's a typical problem that we use for as a workshop kind of problem to teach the idea of what a moldable analysis is and how does it support software assessment and decision making. We use the problem of deprecated classes. So what is that? That means, imagine, so we have this system and we have 2,385 classes here. And imagine that here you have a few deprecated classes. And now imagine that you as a developer, you are maybe in a planning session, and what you want is you want to go and ask for a budget, time budget, to work on removing the deprecated classes. Because the reason you're marking classes as deprecated is exactly so that you can eventually remove them. Now, let's imagine that now it's eventually, and so now we would like to remove those. Question is, how do you approach the problem? And how much would it, how much budget would you ask for? And let's just to make the problem simpler, let's imagine that we only have 25 deprecated classes. And the question is, how do you go about reasoning about it? You can use it as an exercise as well. You can stop the video here. You can think of the how much would you ask for, right? But very often, like when you ask people, we also ask them, how do you go about reasoning? How would you do that? How would you actually, what exactly do you need to ask budget for? And it immediately becomes relevant because, or easy to answer because, I mean, the problem of getting rid of deprecated classes is not a obscure problem. It's a problem almost that you can find in text, in introductory courses to programming, or especially programming with Java. So it's a reasonably well understood problem, and because it's a well understood problem, you would expect that it's a problem that is highly optimized because everybody has gone through it in one way or another. So what does it mean? What does it entail to go and get rid of deprecated classes? Well, first, we have to go and find out which are the classes. We actually have to find the deprecated classes. But at the same time, we also need to see which of these deprecated classes are still being used. And if a deprecated class is not being used, let's assume that this is a closed project. So the simplest possible solution, this is a closed project, and as a consequence, we can just go and remove it because it's not used. But if it is used, well, then you would have to go and investigate the other parts. Now, if you think of these as in terms of clicking actions, like if you imagine your typical IDE with the editor at the center, first of all, finding the deprecated classes is not always the most straightforward. Very often people would choose a regular expression search, which then again assumes that the text that we see in front of us is not structured, not heavily structured, but it's just plain text. Or people, maybe they can somehow find it, but eventually you get this list. Let's say that you get the list of 25 classes, and then of those, people very often decompose the problem as, I'll click on the first one, look at the references, and if then there's no reference, then I can go back and I can delete those. Very quickly, if you count the amounts of clicks, you will get into potentially hundreds of clicks, especially if you have to go and investigate the classes that are using the deprecated classes. Okay, so when asked, people usually estimate on an average somewhere around 4 hours. That's a typical average estimation. And the question is, what can we do differently about it? Now, the interesting part is that the conversation, usually when we're having conversations about how long, how this works, how would you approach the problem and so on, that one usually takes somewhere around 15 minutes. The question here is not what do we do with the 4 hours, but what do we do with the 15 minutes? So how would we approach the problem? Let's see. Hello, Andre.
Hi, Tudor.
So let's see. We are looking at the deprecated classes problem in our UML. So the first thing we want to do, I guess, is to go and find the deprecated classes, right?
Yes, we should ideally not by hand. So we could write some. I mean, we should find first all classes, I guess.
Right. So we can, but basically we could start by writing a query. So one other thing here is I notice here that when I say all annotation types, I can see the deprecated annotation type. So if I click on that one, what do I see here? I see this is an instance of Famix annotation type. So now this one describes the type, the deprecated annotation. And there I can see that there is this interesting entry here which says annotated entities. Now, I said before that there are 25. And now here it says there are 284. So why? Well, because some of them are actually attributes, or maybe they are methods, like here. So the methods and attributes can also be annotated with deprecated. That's why we chose this as a system, because we only have 25 classes that are deprecated, And if you're looking for star deprecated star, you're going to have 284 results, which means that you're essentially having 90% noise of the problem. So coming back to the how would we approach it, we said, let's create here a new snippet. And given this model, what did we say? We want to get first all the
model classes.
So how do we do that? Let's see. Well,
ideally, we need to find out what's implemented there.
What's implemented here, right? So if I click here on all model classes, I get here the FAMIX class group, so with all the classes. But if I right click here, I have this little menu here which says browse the method implementing this navigation. And if I click on it, I'm now getting the method, the GT method that implements the query behind clicking here. So what is the query? Well, here it says self all classes reject each is stub and each is interface. I don't necessarily need to know everything here, but we can simply copy that one. So I can say here, maybe I'll say model classes. And I do that. So self now becomes the model. I get all classes reject each is stub, each is interface. And if I do this query here, I get my 2,385 classes.
Or here, we could also have called directly the all model classes, the method containing.
All we could do, we could have done exactly that one, right? So, but what's interesting here is that once you see a query, right, because all this navigation is a query, if you right click on it, then you can get to the implementation, and this helps you discover that one. So there is also a shorter version of that, which is all model classes. And if we look at the implementation there, it kind of does the same thing. So give me all the classes, reject this stub is interface. Okay, so here we have all the model classes. And okay, so if I look at that, now what do I do with those? So I said that we want those that, I want to find those that are annotated with deprecated, just the classes, not everything else.
Yeah, we have the list of classes already, so we need to apply some kind of filter to just get those that are actually deprecated and not any other.
Right. So what's interesting here is that this one, this model classes is a group or kind of is basically a collection. So I can just use the normal collection API to select things. So here I can maybe select, and given each of these class, well, I'm interested in something like is annotated with, and here I say deprecated. Let's quickly find out. So again, I get a list of 25 classes, and I can maybe quickly check this one. So this is now a class, and I can see here, I can look at the source code too. And what do I see? I see here it's annotated with @deprecated. I also see that the methods are annotated as well with @deprecated. So this is deprecated with is a method, or is, yeah, it's a message that the FAMIX class understands, which means that if I go here and I do self is annotated with deprecated, it will tell me that it's true. It is annotated with deprecated. So this is the reason why we can now write here, model select each is annotated with deprecated, and I get this list of classes that are annotated with deprecated, right? So we can call this one deprecated classes. Okay, so now we have those classes. What do we do next? Well, we should see here, if I look at one of those, I see that, for example, here it says it has clients. So like if I think of dependencies or relationships in source code between entities, I can see, well, if I have a class here that is being used by this class, then this class that is using is a client, right? And this is a provider. So here I can see that I can ask a class for its clients. So how do I find out? How do I ask a class for its clients? Well, I can right click right here and I get the method, which means I can see here it's implemented in FAMX type, and there is a method called client types. Great, which means that now I can go to the deprecated classes. So what do I want? I want to select each of these class that for which the client types is empty.
Yes, so let's remove, maybe it's 25. No, just 14.
They are 14, right? Because there are 14 classes that are not being used. So now we have just solved the first problem. Which of these deprecated classes are not used? So maybe we can call those not used.
Yeah, I mean, these ones can be easily removed. We don't need to.
Especially if we assume that in this case that the system is self-contained. And then, so those that are still being used are basically the other ones, right? So I say deprecated classes, and here I should select those for which the client types are not empty. So that's okay, it's 11, which means that our arithmetic works. 11 plus 14 is 25, that's awesome. Great, so now of these ones, we want to find out which of these we can remove, because that's the ultimate goal. The goal here is find out which ones of these we can remove, and those that we cannot immediately remove, so these 11, find out how would we approach removing them. Oh. And this is where it becomes more interesting. Yes, Andre.
So 11 clicks, no? Or to find out who's using, and then 22 clicks.
At least 22 clicks, right? But then we will also have to go and find out the things that are using, or how are the things that are using it and so on.
So minimum 22 clicks.
Right. So a different solution there would be, we can go on and, for example, write more queries. And find out which of these ones. For example, one of the problem is that what if some of the classes on this 11 are actually also being used by other deprecated classes, right? Then we can maybe remove a whole cluster of them, remove them together, right? But at the same time, it also matters a great deal whether a class is being referred or referenced many times, or whether it's only referenced once. So those will not cost the same when we want to remove them. So basically, at this moment in time, we want to reason about these 11 classes, the deprecated ones, but we also want to reason about the clients of these deprecated classes. And so one way to do that is to indeed do with queries and maybe metrics, but another way would be through some sort of visualization. So let's construct the visualization here.
Yes, ideally we can show some graph and then see how they are called.
Right.
Ideal.
So, okay, and then because it's a graph, we're going to start, we're going to take a builder that allows us to very quickly construct graphs. So this is called Mondrian. Mondrian was a reasonably famous painter, and he saw the world as boxes and lines, hence the metaphor used here as the engine. And so we've just instantiated this little object. And of course, when we inspect it, it knows how to draw itself. But because we didn't put anything in it, it's empty. It doesn't show us anything. So this is Mondrian. And then, so what do we want to see here? We want to see nodes and we want to see edges. So what do we put in the nodes?
Well, we can start with putting first the deprecated classes. I mean, those should be there.
So we can say with nodes. So I'm going to just take the still used ones.
Yes. The other ones doesn't matter. We don't need to put.
So I can see they are here. Right? I expect to have 11. So let's see, 1, 2, 3, 5 times 2 plus 1. That's 11. That's pretty okay.
And now they're clients, ideally, all of them.
And now we also need the client. So if I go here and I'm going to say, okay, we still want the still used ones. And of these, we want to collect all the client types. Is this correct? think so.
Sounds good. But let's inspect the result to see what we get. Yeah. So we do have to do it. Yeah.
I think we have to do a set here.
Yeah, there will be the
Because otherwise we would have the applications and that's not useful. So let's quickly check that. Actually, just let's check this one here. So here we see, okay, we have 24. So these are 24 classes that are using at least one of the still used deprecated classes. And these are here, right? And if we go through all of them, then we have here 30, which means that some of the users of the deprecated classes are also deprecated, because we have 24 plus 11 would have been 35. Okay, so if we draw them all here, they are here. So what else do we need to see?
We cannot differentiate which is deprecated.
Yeah, it would be useful to differentiate because we actually care about the deprecated, not the other ones so much. So for that, I will go and change the shape or the stencil applied for each of these nodes. So by default, we have these small squares, but we can also go here when we are specifying nodes, we can go and specify the stencil that will be given each of these nodes. We can then say here something else. So let's say we maybe want to build element, and in there, let's make those circles. So geometry should be BL ellipse, and maybe the size should be 5, let's say 5 by 5. And what else do we want to say? Well, we want to say, well, let's just first of all see if this one works.
Yes.
Okay, so if I do that and execute this, ooh, there's nothing here. Why is there nothing here? Well, actually there is something there, it's just that we don't see it because we didn't put anything in there, right? So when we are constructing with the defaults, there's already, the border is there, there's a default size, but when we're constructing the elements from scratch, there's no more default. So if we do this, we should see the squares there. Now, of course, we said the whole reason we have done this new shape here is so that we can choose the color here, depending on whether or not each of these class is deprecated, right? So if I say here, each is annotated with deprecated,
or if it's
if it's true, if true, then we use one color, and if it's not, let's say by default we use color gray, and if it is deprecated we use color red. Let's see what happens. Ooh, we're lucky. So let's quickly find out. Let's quickly find out if you're correct. So this is now an assumption here. Like we assume that our code is correct. It looks correct, but it's still worthwhile to double check. And we always notice this type of interaction is being needed every time we do any analysis related either to data or to software. That is, you also have to go and double check as quickly as you can the validity of the algorithm, not only the result of the algorithm. So now here we see some dots, but these are not dots. These are actually, there are full objects behind those. So for example, if we click here on this class, then we can see it over there, and we can go and pick one of them. So for example, this one, and we look at the source code, and then indeed we see the red one here is indeed deprecated. So that's pretty good. We can go back and we can continue. So what else is missing here?
Well, we're missing all the edges, ideally.
Yes. So because we want to reason about how these deprecated class are being used, we want to see what are the connections between all these dots. So we need to create edges, and now we need to tell these edges what to connect. So given every single entity here, given every single class that we see in the scene, what we want to do is we want to connect it from that specific class from all the client types, from all its client types. We want to draw an edge there. So we can say here from all, so given each of these class, we want to connect it from all the client types. I think that should be correct. So if we do that, boom, we can see that there are their edges that appeared.
If you
Now,
drag
of course,
around, should be.
Yeah, no, it doesn't work because the grid layout doesn't allow us to drag things. But if we change the layout, then all of a sudden we can start to see things. So what do we see here? We see that we have interesting clusters here. So on the one hand, we have these two deprecated classes that are using each other. And on and when it means that we can assume that we can just remove those. What else do we see here?
One at the bottom.
The one at the bottom, this one?
The other one, where if we understand one single class on the.
Yeah, here, right? We have two deprecated classes being used by one non-deprecated class. But at the same time, let's say here, it's the other way around, right? We have one deprecated class in the middle of multiple deprecated classes, non-deprecated classes. So that probably is more expensive to remove, right? So this is very cheap because you can just, assuming that this is a closed system, we can simply remove those. But maybe this one is probably going to be more expensive than one of these, right? Because here it's only one thing that we need to go and investigate. Okay, now up to now we just talked about, so this kind of view. What's interesting about it is that we've just created it right now, right? So it didn't take a long time to do that. However, we can actually apply this view on any Java system, right? We can just query any Java system, could be queried by all the deprecated classes. We can find those that are being used, and we can just simply just show this specific graph here, and we can literally apply this to any Java system, and it will give us a picture. So this makes it interesting because, on the one hand, because it is generically applicable, which means that we can, invest the energy once and then get the money, get the return on investment by applying on every other system. However, as with absolutely everything else in software, it's because it is applicable to all systems, it also does not really capture value. It might capture cost, but it doesn't capture value, because value is always contextual. That is, if you have, the value of the architecture doesn't come from the fact that we're using Java. It comes from the fact that that we have encoded the domain in a specific way, and we have taken specific technical decisions to accommodate that domain, and that's what is specific and valuable for a system, and not because it is Java, which means that you have to understand what that specificity is before you can devise an automatic tool that captures it. And it's because of this combination that we can't really rely on clicking tools that we can download from the web. And this is not an unreasonable or uncommon problem. This is something that we have all the time. And this is the reason why we are focusing on this moldability aspect. So how would this value look like, for example, in this case? Always value comes from some context that you already know about the system. If you don't know anything about the system, then this view already gives you some interesting starting points. But that's such a rare situation. I mean, it only applies to people that are maybe joining for the first hour or so in a system. But as soon as you're there, as soon as you had the first conversation about that system, you don't have zero knowledge. You already have more than zero knowledge, right? And the more you spend on the system, the more of that knowledge you have. And the more you have that knowledge, the more you want to customize the analysis to specifically take into account only what you care about. So let's imagine here that, that we already know that the system is split into two larger parts. In this case, it's just a reasonably simple system. it's split into the UI and the non-UI and the model part. So let's say that we just care about, we want to know how are these dependencies going across these layers? Where do we have more of these deprecated classes? Are they more on the UI? Or are they more on the model side? How is it happening? So how do we do that?
I mean, we have to decide how do we identify that something is first.
How do we identify that? So I was going here and I noticed here that we have some classes are just called like Argo UML something, OCL, for example, here. And just knowing some things about UML, OCL is actually a domain model, a domain concept. But on the other hand, I notice here that some of them are actually called something with UI, right? So
the UI package.
The UI, yeah, exactly. They exist in the UI package. So in fact, in this system, there is this convention, and the convention is all the UI classes are packaged in some UI package. So somewhere, and we can let's say that we already know that, and let's use this piece of information. Now, because we already use the background, maybe use the border here. So we say we want to create the border, and or do we need new?
Or maybe border, or maybe a paint. We just give it a paint, yes.
Exactly. And then the paint should say, okay, well, let's just start with something.
Yeah, so the paint in this case is a color,
simple.
but it could also be something else, like a gradient, or not necessarily only colors.
Right. So let's see, if I just put blue there, everything should be colored with blue. Yeah, everything should have a blue border, but we only want blue. Let's say that we only want blue in those that are called, or that are in a package called UI. So I say here each. Now I'm going to look for the fully qualified name. If it includes UI.
What I think includes a substring, or?
Exactly, includes substring UI. And if it's true, then we're going to use color blue. And if false, what do we use here? Maybe we use color transparent. So what happens here, if we execute that one, we kind of get what we want. So we see here that these classes on the left are actually in the UI, and these classes on the right are in the non-UI, so the model side of things. Now, which one of these is more important? And that's a good question, right? And usually it depends. I mean, we know this because we're spending a significant amount of our time consulting, and it depends is the bread and butter of consulting, but it literally depends because it matters a great deal of where the problem is. So for, let's say, if you want to move away from a certain technology, then it would be a completely different use case than if you just want to care about introducing a new functionality and you want to go and refactor your model side of things. But just knowing and the ability to project a custom piece of information about that system onto the otherwise generic visualization completely changes the landscape. Because now we can start to reason, depending on which situation we are in, we can start to reason about not only cost, but also value. And that's basically what moldable analyses are for. And so now let's say that if you care about just removing things on the UI, it's maybe at this moment that, let me do it again. It's maybe at this moment that we care about this specific class over here. So it's now that maybe I click on it and I can see the class. And it's maybe now that I will go and look at the source code. And only now will I go and read code. So up to now, up to here, I haven't read essentially any line of code. And that's the interesting thing, because we're describing, when everything is implicit and we're describing this time that we're spending reading code as a reading activity, then it looks reasonable to simply read. But here we show that, in fact, most of the time that we spent to reason about the problem, we didn't read anything. It's not because there was not a reading problem. It was a search and a visualization problem. And that's basically, that is the essence of moldable analysis. So we always start from some objects, and then that represent the system. And then we use exactly everything else, that all the tools that we have in Glamorous Toolkit to assemble the views or the detections that we actually care about. So this is something that we use for discovery. So if we are in a assessment process, if you look at it like that, then we usually distinguish between one-time occurring problems and continuously, or problems that are of continuous interest. So this is, let's say, a one-time type of investigation. Like, I want to know, what kind of classes do we have in the system? But let's say that I now say, well, I really don't like the fact that that I still have clients for the deprecated classes. So now what I want is, I want to go ahead and maybe follow up on this finding that I still have things that I want to remove. But this will take a while to go and deal with it, which means that now it will not just be a one-time interest, it will be transformed into a continuous interest. So this is where we are using, we're going into the territory of architecture. So we can now express whatever we have learned during this one type of analysis. We can transform those into constraints that we maybe care about for the longer run. So, Andre, would you like to help me create a constraint like that?
Yes. Yeah, we already have the analysis. We already have before an analysis that looks for the classes that we're interested in. So that's the more important part. That's actually the hard part. And
There's
now,
one over here.
Yeah, or usually writing the analysis is the hard part. Once we have it, we should be able to create a constraint and then run it, for example, on our CI.
So how do we run that? How do we call this one? Let's say
maybe
my or Argo UML.
In this case, I should be mapped to classes. So we need to create a constraint. We need to create a class that will contain that constraint.
So how do we call it? Argo UML.
Deprecated classes.
Deprecated classes still used. Or
still
just
used.
Still used.
Still used, maybe more accurate.
Right, so we can say new. Okay, we don't have this class, so we should create one. And then here, I think I need to subclass something, right?
Yeah, so we have it's I think a leaf constraint. It's a GT leaf.
GT leaf constraint.
Yes.
So I have my class and I subclass it from GT leaf constraint. I put it in the Argo UML package. And then I say, okay. So now I have that class.
Now we should also give to this, ideally I give to this class the model on which is going to.
So we can say something like, instead of new here, on model, or just say new model.
New model, I guess.
New model. Okay. So basically this is now a setter. We simply want this constraint to know about the model. And of course this doesn't exist, so we have to create it. And we will store it in an instance variable.
Yes.
Or?
Yeah. We have to keep it somewhere.
Okay, so I'll just create this instance variable. Let's call this one use model. Okay, and then if we save that, then we have here a Argo UML deprecated classes still used. And now we still didn't do the constraints. We have to put this code over here in the detection, right?
Yes, so every constraint, if we are subclass from the GTLeaf constraint, we have to implement a method. So this is the issues method.
So I'll go here on the class side, on the meta side of my inspector in this case. And if I create here a new method, which is called issues.
This is what is the list of entities that do not respect this constraint.
So those that invalidate the constraint. So we can say there, okay, what do we have? Okay, so we have here model classes.
You can copy the snippets and then.
And we can copy all snippets like that, you say. Okay, I'll put those as a temporary, because I use the same model, so then I don't have to do anything else. Then I have to find deprecated classes. And this is also temporary. And then I'm gonna look at still used.
Yes.
Exactly, let's see. So I'll make that one a temporary as well. So now when I save, what happens? I get here an issues tab. And there I have the classes that I had before, right?
Yes.
So these are those classes that are still being used and they're annotated with deprecated. So this is something that we can then take care of. Now, of course, we also have this one over here, because that is interesting too, because it was kind of an interesting tool. Not only do we find what classes do we care about to maybe remove, but also documenting the value part is also interesting, right?
Oh yes, definitely.
So what could we do with that?
Well, we could put it in a new constraint, but that might not make sense. But we already have an object. And this seems very much like another view for this object.
So you're saying here I have a constraint. So one option here could be that we create another constraint and something else for the visualization, but then we already have here a detection that already is about the classes not being used. So what we could just do would be to create another view right in this class, right?
Yes. So then when we look at the deprecated classes, we either get the list or we get the graph of their dependencies within the system.
Right. So let's create that one. So we call it, graph. So the way we create a view is always, we have a method that gets a view builder as a parameter. And we annotate it always with the GTView pragma. And then we say here, and we want a view. And here, notice how we created here a Mondrian object. We explicitly created, and we can also ask the view here, well, we just want a Mondrian object. Let's give it a title. The title should be graph, could be graph. And then a Mondrian view already produces a Mondrian or gives us a Mondrian variable, which means that if I can just paste the code that I have here on the left, it kind of works, except for the still used. And basically the still used are, I should go and compute those, but I already have them here, because if I do here, self issues, right?
Oh yes, there's the list of issues that.
It's the list of issues that should work. What did I not? What did I do wrong here? I think I copied something the wrong way. Let's see. I have this one.
Feels like it's closing.
I think this is good. Yes, so I have that one, a Mondrian mu nodes with, and then I have here the edges, and I have the layout. And if we execute that one, then the graph appears here, and it should work. No, it doesn't work. Why not? What did I do wrong here? Ah, I only copied probably. I see what I've done. Let's do it again.
And we should return the view at the end.
Right, this is the view.
And in the painting. No, in the painting, we should not return the view.
So we take this one over here, and I'm gonna paste the whole thing inside. And
But
this should work.
Still use this not initialized right now.
Yes, it is not initialized.
No, if we go to the source of the view,
Here.
it's at the top. We define still used at the top, but don't put anything into it.
Ah, okay, yeah. Still used should be self issues. That should work.
Yes.
Ideally, hopefully. Let's see. Are we lucky? We're not lucky yet.
Do you need to return yourself? I don't know if what does still the method you were using.
There. Huh. I don't understand what exactly we're doing here.
Well, live debugging.
What does the painting? What does the painting method return?
No, look at that.
Yes.
We put it in the stencil block. We initialize it in the wrong place. Excellent. So now, if we look at it now, yoo-hoo, now it works. Great. So we have our view, we have our description over here. We have the issues. We can also attach a description and it will appear here. And so that will be the constraint view. So what do we do with that constraint? Well, the constraint, we add these constraints. You can think of this constraint as being, it's like a test now, but it's not a functional test, it's a structural test. So we can now add those into, reports. Now the thing is, we already have this report implemented. I think it's called Argo UML report. And we can say new, or is it on?
Argo UML report. I guess it's, let's see, what can it be? I think it's on model.
It's on model. And if we execute that one, here we have 3 of them. Why 3? Well, this is the one that we have, or similar to the one that we have just implemented. A little bit more elaborated. So I have the issues are over here, the issue detection. We have the view of dependencies with this graph view, same way as we have done it before. In this case, we also have a stakeholder, and we also specify something here called status. So what is this status? Now notice how here we have a gray button. This is a gray button because let's say that we want this, we've just discovered this problem, and it will take a while until we fix it. Maybe it takes, I don't know, maybe a week. Because maybe we don't do it everything at once. Maybe we also need somebody else's help in the team. So it might take a bit of time until we actually go and fix it. And so, but at the same time, we still want to document the problem. So this is why if we say that the status of the constraint is neutral, this will not break the build, because we can now take this Argo UML report, put it into, for example, a Jenkins or whatever, your continuous integration server, and it will simply run this report and produce results like if they would be tests. But in the case of neutral constraints, they will be, they won't break the build. So they will not appear as being failing. And here, for example, we have a green report, a green constraint. So what is a green constraint? A green constraint is one that has no issues. If there is nothing that breaks the constraint, and all of a sudden that is a green constraint. And then here we have another kind of a constraint that has violations, but in this case, we want to know about those. We want those to break the build, and they appear here as yellow. So again, the interesting part here is not only that we have written the rules, but also that now when something is broken, we want to know why. So the description is also important here. In this case, we see classes representing widgets, for example, those specifically those that are inheriting from Java AWT components should be placed in packages that contain UI component in their name. And those that not, then it doesn't matter. So this is one place, one source of information. The other source of information of actually knowing or understanding what kind of trade-offs did the query or the constraint take when it failed, we can simply take a look at the code. And this is where the conciseness part of the detection matters a great deal. Because for the long run, you do not want to spend a long time maintaining constraints. But here you're seeing that the way we've developed constraints is exactly in the same way as we develop anything else in Glamorous Toolkit. With exactly the same development tools, the same kind of feedback loops, the same kind of debugging abilities, which means that it's already real or interestingly, like we have a development environment that now, because we have applied it on an architectural or something that is perceived to be an architectural problem, we essentially have a development environment for creating architectural constraints and documenting our systems through automatic means. At the same time, because we have these interesting, concise APIs, these APIs allow us to write constraints in a short amount of space. And this is particularly important exactly when you want to reverse engineer and find out why a constraint has failed, because we started from the beginning saying the only measure of success for any analysis effort is whether or not it changes your mind. So if you know something more than before you've done it, if you don't know anything more, then it's not particularly useful. It doesn't matter how interesting or it might appear. It's not useful. On the other hand, to actually go to actually take an action, you want to know most of the time the details of the detection. And that's why this little snippet over here essentially acts like a legend, like the specification of the problem. And this then informs how you want to go about fixing it. So what do you think, Andre? Did we cover what we wanted?
Yes.
I think so too. So let's maybe stop here and take questions. So Oscar, I can see here that is asking about the meaning of what is a model. So on the one hand, the model is, the model is the representation of the system. And we can obtain that model in various different ways. So in this case, we have obtained it through an external tool that has produced a detailed model of the Java code, but equally interesting could be to have a logic that imports, and that logic is implemented in GT. So for example, for JavaScript or for JSX and React, we already have models or importers for that produce the model with logic that is implemented directly in Pharo. Similarly for C++. So there, every importer will have its own API, and this is, you'll ask the importer, please give me your model, and then you will get a model. And once you have a model with objects representing the actual target system, then you get to use exactly the same tools that you're using for any other Glamorous Toolkit activity. But in this case, it will be applied on a completely new domain, and that is the domain of, maybe some people call it, steering agile architecture, or structural tests, or even fitness functions more recently. Yeah, I can see here Konrad saying that he is relieved that even Pharo experts get lost in brackets. The good thing is that we have less brackets in Pharo than people have in Lisp. So this does happen, but it happens less often. But yes, indeed, that is still a problem. And we actually we're thinking about how we could suggest people different different heuristics to maybe they are in the wrong at the wrong nesting level. But that's something to be played with at sometime else in the future. Are there other questions?
There is one in the chat from Zoom.
I can see from Felix. So Felix points out that that in this case, like in the case that we have just played with, the deprecated classes case, the deprecated classes are very easy to find because somebody already tagged the classes as being deprecated. And that somebody had to find those that had to be deprecated. And the question is, how do you find the classes that are being deprecated? And this is where it's always, we get these kinds of problems reasonably often. Now, how do you detect that a class should be deprecated? Well, the intent usually predates the action. That is, oh, I really don't like the fact that we're using this API. I want to use another API, which means that I'm going to go and maybe either develop it in parallel, or maybe I already started annotated with deprecated so that others know that it should not be used. But at some point, I am the one, I'm intentionally deciding this is no longer wanted for whatever reasons. The reasons can be of various kinds. Maybe I just evolved for maintainability reasons, the library that I'm using. But it can also be maybe for performance reasons, maybe for security reasons. It can be so many other reasons that accumulate. And at the end, like in this specific case, it's the user, it's a designer that wants to annotate and says, now I want to mark and communicate to everybody else that now I don't want people to use this class. Now, what is interesting here is how that at the end, right, this annotation of deprecated is essentially a convention. And conventions is something that we're going to see very, very often. We are seeing very, very often every time a team works on something reasonably complicated like a software system. And those conventions, they encode kind of like a higher level mutual understanding in the team about what is important and what is not important. And in this case, we've started with something that is generic simply because this is something that is widely understandable as a problem. Like for everybody understands the deprecated classes problem, but the essence here is not that we can go and find the deprecated classes. The essence here was we take some problem, we start from some problem definition, and then we iteratively construct tools to expose the various facets as we go along. And so it's the process that is the most interesting, because this problem, right, is super, everybody knows that. But in larger or longer living systems, you will have much more specific types of problems. And this skill of transforming a problem into a detection that then informs action and corrective actions, that is the essential part. And that is what we wanted to emphasize here. The other thing to also, talking about the deprecated classes problem, the other thing to remark here is that I started from the beginning saying that it takes people about 4 hours to, or people estimate 4 hours of time to go on the low, this is like the low medium estimate, to go through this problem. So this is like the time budget that they're asking for. But here, even with all the explanations, it maybe took, perhaps less than half an hour. So And we, without explanations, these kind of problems actually can work within minutes. And so even for a very simple problem, we see a difference of at least an order of magnitude. And that's very, very large for a problem that is supposed to be very, very common, because a common problem is something that has been optimized significantly. And so seeing marginal improvement is possible, but seeing an order of magnitude improvement, it's not reasonable unless that problem has never been optimized before. And that's what, this is where we started from. The very fact that we're not talking about how we read code is, in fact, this is where it leads. It leads to this highly unoptimized means by which we go and reason about our systems. I hope that addresses the question. The question here is, yes, Felix says that I have addressed the question. Team is asking if we have thought about viewing these constraints over time, such as in time series, to basically see, deprecation, growth, contraction, and so on. Indeed, absolutely. All of these things are absolutely relevant over time, like with anything. But where we are focusing right now, and where the simplest or the most immediate return on investment literally comes from one's ability to take a problem that just appears right now and then map it onto something that we can see immediately. Time is absolutely a very interesting point. Perhaps we can address it in future sessions. But the essence is here that you can get a lot by just investing into this immediate skill of transforming problems into questions, into detections. Good. Are there other questions? Okay. It looks like we have addressed all possible unclear issues.
One thing, Tutor.
Hello, Oscar.
Only questions about this live session, or do you let questions related to something that I asked before and I have not completely resolved?
Go ahead.
In last days, I asked you about the documents, for example, for translating. Do you have an example where I can find a pillar document of one of the documents, blogs, slideshows, or similar you have in your playground? Oh.
I'm not sure I understand the question.
One of the questions that I asked you last day is, how can I translate a document? In understanding as document, I don't know if a slideshow, a blog, or local file. You told me that you use pillar you store documents in a pillar file. Okay?
Yes. Yes.
Can you show an example of a pillar file in your work where I can find them? Because I saw the presentation, I find a visual representation, but I don't know where those documents are stored.
So here, for example, the question here is, where are these documents? For example, the ones that we see over here. Where is this coming from? So when we go over a document, we see here, and there is a tooltip which says GT, in this case, GT create standalone app how-to guide. So let's say GT create standalone app to guide. So what is that? Well, that is a class. And in this class, we have a comment. And this comment is, because it has this extra markup, becomes a live document. Is this what you were asking for?
Yes, but I don't know how do you create, how do you modify? You did.
This is a class. This is just a normal class, just a class. And this class has a comment. And in this comment, we have this piece of text. And that is it. That is.
How do you make bold tests, for example? I don't know.
This is a markup here, and you have to go and learn the markup in order to utilize the markup. But it's a markup like any other.
It's not markdown. It's not markdown.
Not at the moment.
Okay.
Perhaps soon.
Is there a textual representation of this content to be edited with a bin, for example, in a Unix machine? Or you only have the only possibility to edit that document is in this live WYSIWYG editor?
This is not a WYSIWYG editor. It's a in between WYSIWYG and edit view. This is an actual text editor. So for example, if you see here, I expand all of them so it doesn't apply all the time. It doesn't hide when the mouse moves away. So this is a full text editor here, just like any normal editor, except that it has these previews, which are automatic, but that should be considered as an enhancement and not as something that is not desired. So where would you like to edit these ones? Can you edit them in a normal text file? Yes, of course you can. Like for example here, if you're in a playground, and let's say that I'm interested, I'm just doing my test pillar, and then I'm doing a file reference over here. Right, stream do. So I'm just creating the file here. And if I'm doing that, and let's say I'm doing yourself, I'm getting my file reference over here, and it has a document. Like now starting here, this is a test. And now I can make it a header, and this is some content. And so now here I could also do I can just add any other things here. For example, I can say I want a class, and maybe I'll just put here a reference to a picture, to the picture class. And if I click on that class now, it will get me to the comments of the class GTCS picture. But here, this is actually just a normal file. Just a normal file that exists here in the root directory. So if we now quickly investigate the root directory, we see here that we have test.pillar. And if I double click on that one, I will see the file. And of course, where I can see the contents. Contents are just this text. Does this address the question?
Yes, thank you.
Great, I'm glad. Now, one other thing that we didn't show here is that we can, once we have texts or files like that, it's also possible to actually create live documents about architecture, because now we could see, we can actually capture constraints as real objects. We can see the results, and there is also a way in which we can take those results, put them into a document, and then actually construct live narratives or live documents that document the architecture of the system, not only maybe domain objects. But we leave this one for another time.